In this lesson, we're looking at the average value of a function. So if I have a function that's changing, and I want to spread it out and thinking about if it was constant, what would it be? That would be my average value. So we'll do that by finding the integral, which would be this blue area, and trying to spread it out into a rectangle, which would even it out into an average value. And so we would do that by taking the integral over that interval in question, but then splitting it up, dividing it by the distance that we're covering. We're going from B to A here. As an example, if we're dealing with a velocity time graph, and we have an integral going from 1 to 5, whatever our function is, that's giving us a value of 20. So in this case, since it's a velocity time graph, we would think about that as being measured in meters. If I wanted my average velocity then, we think of the average velocity as the distance we've traveled, or really the displacement, and we would divide that by the time. Now in this one, the time's going from 5 to 1, so we take 5 minus 1. The displacement was that 20 that we found. Now our average value function that we were given on the last page would be written out like this, which is the same thing. Notice then that our time down here would be in seconds, our distance is in meters, which would end up giving us a value of 5 meters per second. So even though our velocity is changing over here, we would have an average velocity of 5 meters per second. In this problem, we are asked to find the average value of f of x over this interval. So that's going to be the function that goes inside of our integral, and we're going from 0 to 3. If we're looking for the average value, we'll write that average of f. That would be 1 over, and we look at our interval again. We're going from 0 to 3, so that'd be 3 minus 0. Now to work this out, we haven't learned how to work out these intervals yet. So I'm going to show you how to do that on your calculator. Now your calculator will allow you to just plug in integrals. If you click on this button here and choose this button here, which is an integral value. Now notice it allows you to do a lower limit. So just plug it in as we see it, an upper limit. We plug in our function, and then we plug in a variable of integration. It has to know what variable you're using, and then hit enter. So that gives us a value of 3 for this problem. So using that, since we've used our calculator, that gives us 3, and then we can multiply, and it gives us 1. Now that answers the first part of the question, find the average value. But we also need to look at the second part of this question. Does it actually take on this value at some point in the given interval? So we want to look, what we're looking for is there anywhere that f of x is equal to 1? Remember, this is the average of f, so this is actually a y value. So we take our function, 4 minus x squared, and see if there's anywhere where it's equal to 1. Working this out, we're going to get x is equal to plus or minus the square root of 3. Now it is important, they say, at some point on the given interval. We're only looking at the interval from 0 to 3, and so our answer here would just be the positive square root of 3. This leads us to the mean value theorem for definite integrals. Notice that we're starting here, this is our formula for our average value, but what this theorem is saying is that if our function is continuous on that interval, then there's some point where we have to meet that. And so if we're going from A to B, there must be some point C on this interval where we are actually at that mean value. Okay, in these problems we're going to find the average value for these. This is just a couple more examples. Notice that my shape here would be a triangle for f of x going from -4 to 2, which is why I've used -4 to 2, which would give us a 6 here. I could calculate this integral using area. It's a triangle with a base 6 and a height of 3. So my area would be 1/2 the base times the height, which would just give us 3 over 2. Now if we wanted to find somewhere on this interval where we're actually equal to that value, notice that there's two places, there's two x's where we're equal to 3 over 2. And that's happening at -2.5 and 0.5.